Well, hi, good morning, and thank you for joining me in my shop. Today is June 11th. Man, it's cold around here. I know so many parts of the world are super hot. Here, it's cold. It's the high today is 19 degrees Celsius. That's cold for June. And the day started out at 13 degrees. Very cold here. So, now I was in my shop yesterday working on this radio. I made a video, didn't post it in the end. And the reason for that was, well, nothing really happened during this video. And at the very end, I discovered I'd made a significant mistake in everything I was doing. So I didn't really get anywhere. The reason I didn't get anywhere, and by the way, what I'm doing is I'm trying to align the radio. The reason I didn't get anywhere is because of instability in the radio. So I tuned it in to a certain frequency and something is drifting somewhere. I don't think it's my signal generator. And with it drifting, there's no way to do an alignment because the signal level is going up and down as it drifts back and forth. And it's no way to do it. So I spent most of the video trying to track down where this instability was coming from. Right at the end of the video, I realized I put the wrong size dummy antenna resistor in here. So I put a resistor in here. I thought I was putting in a 390 ohm resistor. I didn't look at it. I should have looked at it. It's a 39,000 ohm resistor. That's probably part of why I was struggling so much yesterday to do the alignment. Now I did manage to align something in this radio, but I'm going to repeat it all today. And I'm going to put the proper size padding resistor in here. And I don't know what effect this would have, except I had to have the signal generator cranked very high. And then I think some of the signal was leaking into the radio. It shouldn't have been, and I don't really know. Anyway, I was a little bit frustrated with the situation at the end there. So, okay, I'll get all this set up and get the equipment warmed up, and we'll get going on the 1650 alignment. I think that's what I'm doing. Is that what I'm doing? I'm having coffee now. I'll know better after a cup of coffee. Last thing I did yesterday was hook this up to an antenna, so it still is connected to an antenna. Why don't we just run through the fans kind of quickly and just get a stock of how well this radio is working. Now I have put in the suggested value of resistor here, but look at the difference in the signal strength if I just... Now it's quite a bit. So I'll carry on this way. This is with the volume full, so this is not so good. We're on the top band, kind of in the middle of the dial here. It's 25 megahertz. There's going to be nothing up here. Let's see. What was that? Something came and went. This is the 16 meter band or 17 megahertz, nothing. See the volume's down quite low. The strong signal is producing a good result. AVC seems weak in this radio because when I tune off, silence. You'd expect the AVC to bring up the radio's strength. Sounds nice. Okay. I'll be the AVC. Trying to get WWV here. There it is. So now we can take a look. That's pretty accurate. Sorry it's a little out of focus, but you can see it's right on 15. That's good. Okay, reception's not that bad. The ham band here, 20 meter ham band. There's the FT8. You notice it's full of tones, even though I've got this set on AM. It's not on a single sideband. Quiet, isn't it? So I'm going to move the antenna straight on here. Yeah, not sure the advantage of that resistor. Maybe in comparison to a piece of equipment like that, my antenna is probably a little bit of a higher impedance. So selectivity doesn't seem to be correct. Yeah, that's the lowest. That's for CW. And very sharp. I can just barely hear it there. Okay, that's that band. So, we can declare that band working, that's for sure. Go down. Now, see the difference here? Listen to the hiss. What happened to the hiss on the other band? I assume the hiss is a good thing. This is 6 megacycles here. Shouldn't get anything down here. Okay. Around 9.
9. They're all estimated on. I've read actually that if you compare ages.
Now that's a very strong signal. Yeah, the meter's barely moving.
Working command of the language. Polish. Yeah, it's the most difficult language. Absolutely.
Polish? Polish is the most difficult language in the world. Okay, so we can see this band's working. Okay, we'll go to the next band, where it's going to be difficult to prove, well, even more hiss. Wrong one. And, 4 megahertz, we're not going to pick anything up down here. But it's receiving noise anyway. Right down into the AM band. Now, okay, so those 3 bands, they're all more or less working. This last one, this is the one that okay, well, we're getting some interference. Should be a strong signal coming in right here, right in here. So this is the number 1 band, this is the broadcast band. Something is not right with it. It does pick stuff up here. It did in the past. We're on full blast here. Nothing. So something going on with that band. Every time I've checked it, it's either been so weak as to seem to be dead. So this is 15, 20. There's nothing up there to pick up. How am I getting something? Oh yeah, one of the things I forgot, this antenna tuner is really critical on this radio. So maybe that's what's been going on here. No. Oh. Strong signal right around here, 680. Everything's turned up now. Very weak. If it's working, it's weak, and I don't think it's working properly. Don't know what's going on, but okay, that's the check. So we're getting various responses, various bands. Now, what about the stability issue? So we'll go on the top band. That's where I was experiencing this stability issue. That sounded kind of nice. And you have to get it off the antenna now. And we'll put it on the signal generator. Just sending out a signal at 14 megahertz, so we'll tune there. And there. Here we go. Now, there it is tuned in. So we're going to watch it on the meter here. This meter is connected to the audio. It's gonna, you know what? This is going to take a minute to warm up and stabilize. So, coffee break time has come. Then we're going to look at this meter and watch its action. See how stable the radio is. Okay, let's see how steady this is. Now I've got a voltmeter hooked up to the speaker. I can take the speaker off, the connection off, so we don't have to listen to it. Turn the volume up. We'll see the meter come up here. Okay. There. We don't need to listen to it. How steady is this? Now, yesterday this was not steady at all. This was jumping all over the place. This needs to be steady if I'm going to do an alignment. And it sure looks rock solid now. This was jumping down and up and down. And we need to pay some attention to its drifting over time, but I mean the set is still probably warming up. Well, that's rock solid. That's perfect. That's good. So that's at 14 megahertz. Let's go up to the other end. The instability I was following was up at the 30 megahertz end of this band. Wait, which band are we on? I'm not even on the right band here, am I? Yeah, we're on the high band, the low end of the high band. So I'm going to dial this to the high end. We'll stop at 30. And I'll dial this up to 30 also. Now, could it be my signal generator was jumping around? Never experienced this jumping around, so I don't think so. Okay, so we'll tune it in on the radio now. Very, very weak. How come so weak? How come so weak? Everything is turned right up full. You can barely hear it. Why? I mean, I have the signal generator not even using the resistor here. I've got it connected straight to the radio. Antenna? A little bit of difference, not much. So I've got a fairly strong signal coming from the signal generator. Alignment issues? Let me set this right on. Okay. This will never do. Full tilt. Maybe my signal generator output may have dropped off. I'm right at the end of one of the scales here. So let's check. So we're checking this meter. No, it's right on. It's calibrated right on the money. I got the wrong cord hooked up? No. So this should be blasting out of this radio. It should not be coming out the way it is. So the volume turned up full, we can barely hear it. Is it because I don't have the speaker connected? Well, that could be the case. Yeah, that could be. That could be the case. So what we were hearing, if you were hearing it at all, is something in the radio acting like a speaker. Let's see what we get this time. Oh yeah. Yeah, dumb mistakes, eh? I make them. We got something flying around in here. What is it? Okay, now I think we're ready to go. Well, now we can probably watch this meter again for stability issues. Let's see. Now the instability, you couldn't really hear it. You sure could see it. Okay, now this is going to get really loud. Not really loud. So I'm going to take off the speaker again. Okay, because everything is working fine. Put this up and watch this meter. It's drifted down a bit there. So the drifting would, if you actually measure the voltage here, so 1.5 volts. So we're right in the middle, about 7.5 volts right here. It would drift down to 6 and up to 8.5 and back down and just around kind of erratically. That's what it did yesterday. Today it's rock solid. Is it because I had that huge resistor as a dummy antenna? It doesn't really make sense to me that that would be the case. This is stable enough I can do an alignment. There it goes. Now it's drifting up. Drifting up a little higher. If it's very slow drift, I can probably get away with it. Alignment. Now it's going up. Now this is more what I was seeing yesterday. Yeah. Yeah. Okay, that was not very good. Who's drifting? So I'm looking at my signal generator. It's drifting around. The last digit is drifting around. And you could always ask, is that the frequency counter that's drifting? Now it's going to be stable. Let me put it right on 30 here if I can. That's probably exactly 30 there. Tune this guy back in. Let me put the speaker back on. Sounds right, looks right on the meter. I wish I had a little more sensitivity to get this up. I'm going to take off the speaker again. There is a dummy resistor, so the radio still has a speaker load on it. We'll turn this up a bit. Yeah, this could even be dirt in the volume controls, or in this control too. It could cause this to drift. I'm pointing away at it. You're not seeing what I'm pointing at. So it's right on the 7 right now, rock solid. Again, slow drift isn't going to trouble me during an alignment. It's the quick drift and the sudden drift away. Let's try a little shock here. I'm going to bang the bench basically. What was that? Wow, what's doing that? Not expecting that. It's got to be something in the radio, Jim. You're fooling around with the radio. Wow. It's right in the area of the IF cans that I'm going to be aligning. Now I am up at the highest end of the highest band on this radio, so I'm probably in the spot where the radio is most sensitive to this kind of stuff. Little variations show up, have big effects, I think. Oh, how come it stopped? There it goes again. So I had discovered that moving any of these wires any distance in here, up here in particular, will cause an effect like this one here. If I just move it a little bit. See how sensitive that is? As I said before, this is a very sensitive setup here. Up to, you can see what would happen if you're replacing parts in here and wiring them slightly different. You're going to get a different result here in the radio. That's why radios need to be aligned. What's going on down here? So sensitivity everywhere. This is the, I think this is the oscillator tube here. It's just sensitivity everywhere. Wow, think about it. You could design a radio, get the whole thing built, let's say a mock-up of it, or there's a word for it, prototype built, and then discover that it's full of these terrible sensitivities like this. Especially, in the extreme areas, like the highest frequency, maybe the lowest frequency, end of the band ranges, or I don't know. So I'm just going to compare the sensitivity in different locations here. It's going to be all around the oscillator, I would imagine, the oscillator circuits. Where nothing down here. This is all audio down here. It's all going to be up here. I think this is the oscillator window here. Up in here. So I think just about anything. Watch out, there could be some fine wires in there, so I'm doing this very lightly. When I get down in this area, this is where the sensitivity really takes off. Wow. I also noticed just getting close to the radio. So I'm bringing an alignment tool up. My hand is coming up with it. So I've picked some fairly long alignment tools to try to keep my hand away from affecting the radio. You get a shock doing this. Again, it's this oscillator area. Now I did also, I'll do it again. I thought, well, I haven't got the bottom plate on here. I put the bottom plate on. Won't it drive everything crazy? So watching the meter now. And the very, very small movement. I think I'm banging some wires and stuff to it. So not much effect. That's an aluminum base. Maybe because it's aluminum, it doesn't have much effect on anything. So you can see you got to make all these adjustments and then put the base on, and everything's gone off. So I really haven't checked through here. This is the other IF area here, the IF area here, and an IF area here, and this is the crystal. This doesn't seem to care very much what's happening. There's a wire running past here. If you move the wire, you get a strong effect. Not back here though, just up in this area. So none of these things are going to move on their own though. What would cause it to drift around on its own, which it's not doing? I put it down to the tuning capacitor rotor not making good ground contact, And I did treat it with some, I tried 2 treatments on it because the first one didn't seem to do much. Deoxit, and I gave it my old standby WD-40. Maybe overnight it did something to settle it down. There's another capacitor here which I did not treat, which I'm going to treat now, even though there's no indication for the need of it, and that's the this one here. In fact, I really didn't do a number. I'm making claims here that are largely untrue, so I'm going to go just with a little WD-40. We're going to try. Oh, that's interesting. These plates are brass, I think, and these ones are probably steel. Wonder why? Why brass plates? So, okay, so I want to hit the ball bearings here. Just a little dab, and the point back there, and then there's going to be some contact, like sliding contacts right in here. Okay, likewise on this one. Wow, I can't even see in there. So I can see where the how they've done the contacts. It's a used a flat piece of metal bent over like this, slid on this mount or on this part of the frame here, and then it goes down and it touches the rotating shaft and has a springiness to it. That's the idea. And the contact part is right in here. Putting the tiniest amount of this stuff. Okay, also notice it looks like the outside plate here, I was flicking some dirt away in case you wonder what I was doing. These 2 outside plates appear to be bent outwards slightly. And I want to get right down here. A little shot. This is a gear driven. Oh my gosh, it's gear. No, it's not gear driven. So the tuning capacitor is gear driven here from the big knob. But there are strings in here. The string here. Oh my gosh, it's more than a string. So I got a string driving the wheel. Then there's a steel wire here. You can't even see it. And that's driving this. Steel, of course, doesn't stretch, which is why you would want to use it. But the string. And of course, I've been hearing the bonging sound of the string here. That sound. So what that sound is, the string way up in here. This is hard to see. I don't know if I can get the camera really close enough to it. Right in here is a U-shaped valley, if you like, for the string to run in. So the idea is, as you turn the knob, the string will get pulled to the bottom of the valley over and over, and it'll actually slide smoothly into the bottom. Basically, if you look at it, it'll stay in the bottom of the valley even though you're turning it, and even though it has a, it's trying to climb out, if you like. And this radio, every time the string moves, it makes a bunk sound, like that sound, that sound. That's the string shifting back into the groove. What I was worried about was that the string is going to go over top of itself. So I'm just looking at it here. It's doing its best to climb right out of the U, but it can't. It can't do it. So if the U becomes a little rusty and starts gripping the string too hard, the string can't slide back to the bottom of the groove. It's being pulled, right, by tension. So it wants to go to the narrowest part of the shaft. So it's going to try to get down to the bottom. And at the same time you're turning it, it's trying to climb its way out. And you get that sound. If the U was smooth enough, then the string would just slide. You'd never hear this. There's probably a little bit of rusting in there. But it's not causing a problem. Okay. What's this meter doing here? Oh, what have you been looking at? What happened here? You're looking at my computer screen. Okay, where am I at? So I fiddled around here for a long time. I haven't actually done any operation on the radio. So we're going to do the 1650, redo the 1650 alignment after a short break here. So one of the things I want to make sure of is the local oscillator is set above the target frequency. So the target frequency right now is 30. I've got this tuned to 30, and you can see the signal generator is putting out a 30 megahertz signal. And what I've done is I've got my SDR radio, the loop, you can see it's just sitting here on the bench, quite a distance from the radio, but that's still close enough to pick up the local oscillator in the radio, which should be running 1650 kilohertz above the target frequency. So that would be 30 plus 16 is 3160. So we'll look at the SDR now and we'll see. So I've got, just double checking, this is tuned right on, not quite. It's tuned right on 30. And the band spread is right on the mark. Okay, there's no parallax error in that setting. So we can see the signal dropped here because it's not correct. Let's look now using the SDR and see where the local oscillator actually is. Okay, so here's my SDR, and it's picking up various signals. Who knows what these things are, but you see a strong one out here, right here, at 31,695. That's the local oscillator, and where we really want it to be, it should be sitting here, where the red line is here. So I'm going to move the oscillator adjustment while you're watching that screen. This is just a capacitor. Let's see how this goes. Everything's moving up there. Getting the wrong way. There we are. All those other things are probably artifacts from the conversions that are going on in this radio. So you can have all kinds of frequencies if they're outside of the IF. What happened here? If they're outside of the IF frequency, or frequencies, as in this radio, the radio can't hear them. So some of these radios, my experience suggests to me, they are full of all kinds of weird birdies, and the mixer is mixing all kinds of stuff that you might not want it to mix. Now I'm not touching anything. I'm standing still. And we can see the local oscillator is unstable. Well, it's become stable now. So my guess is I'm turning the adjustment. I'm not turning it now, but when I turn the adjustment and then stop, it takes a moment for the adjustment to settle. And we're talking about molecular motions here. We're talking about the tiniest little. I'm adjusting it again. Wrong way. We're talking about the tiniest. Whoop. See, and that jumpiness also suggests that it's going to have this relaxing problem to me. It's just jumping back and forth. Come on, just. I need a bigger, stiffer screwdriver is what I need. There we are. Okay, so it's right on. I'm not touching anything now. That looks pretty good. Now, what if I tap this radio? Okay, I'm gonna wrap the radio here. Hello, anybody home? So that's where I really want it to go. So maybe that's a good thing to do. Let me tap. I'm gonna tap right on the side of the adjustment. Nothing. You know, that's not a bad idea to try to settle these things in after. Let me put it back. Okay, and wrapping the radio. Maybe something else is drifting. Just a touch. Giving it a pretty good shake. Now you could see yourself aligning a radio like this and then carting it off to some other location and banging it here and there and finally getting in place, and the alignment's been knocked off if it's that sensitive. Okay, that's about as good as we're going to get that. Next step, let's get off this. Get off this screen. So next step, we're going to want to watch this guy. How come this isn't? So this should be up because I have the local oscillator correct, I have the dial correct, and I'm sending in exactly 30. I'm not sending in exactly 30. My signal generator is drifted downwards a bit. That's where we want it. Okay, I did not bring the meter up. So now where is it? Where is the where? So I'm going to tune the. What should I do? Tune the signal generator or leave the radio? The radio is set right on 30. Let's tune the signal generator. So what I'll do is you watch the meter. I'll move the generator. So there we are. Look at the frequency on there. Why did it not? Why did it not? Well, let's look at where the frequency. Let's look at the SDR again. Oh, you know what it is? It's not 3160. It's 31650. 650, Jim. That's really where you want it. Duh. Yeah, I did it wrong. Okay. Let me put this back to 30. That's the signal generator. Okay, so the signal generator's on 30. Now, we want to get that local oscillator over to the red line. Okay, let's try it this time. I did a very precise job last time, but it was wrong. Okay, wrong way. Go this way. Wow, okay, that's right on the money. Very good. Look at the meter. You can't look at the mirror. Watch the meter. Let me just come back. Went away. Okay, so my signal generator's gone a little high. Let me bring it back here. It's the signal generator. That's just a touch low. It's a signal generator that's drifting around. Is that the signal generator doing that? I'm not sure of that. I have no other signal generator that'll do this kind of frequency stable. So that sounds like a radio, that sharp coming and going. You can watch the numbers on my frequency counter here. You can hear it's gone low. Yeah, that's a signal generator jumping around. Okay. I think that's as good as we're going to get it. Now we'll go down to the other end, 14. We'll see what's happening down there. It's 30, right on 30. Beautiful. All the way down to 14. This is the recommended frequency. 14, okay. And 14 here. If I put this right on 14. Oops, and then I dial the radio to tune it in. You can see how far off it is on the half a width of the needle of the pointer. Some funny sound to it. Well, there's nothing to adjust there, I don't think. One thing I didn't adjust was the antenna tuner. It was dumb of me. Guess you just do it at the high end. We'll go back up there. So you tune the local oscillator, then you adjust the antenna trimmer, oddly enough. Let's go back up. What's that? What the heck is that? What's going on here? Some point at which it receives itself and is causing motorboating feedback. Not supposed to do that. Okay, I don't really know what that is, but it's right on the 30. Pretty. Let me set this right on 30. It's just off the 30. That's 30. Now I forgot what the heck I was doing. What was I doing this for? 30. Antenna trimmer is what I was doing it for. Okay, tuning in the radio just to get the maximum on the meter here, so we can see it. Okay. Okay, now antenna trimmer. Last thing, sound off. Oh, that's hard on the ears. We adjust. We're at the 30 again, so we're adjusting this guy here. I had it adjusted. Such a hair trigger at 30. There we go. Okay, it's not going to get any better than that, I don't think. Now, there are, at the low end, there are some inductors to change. Let me show them to you. You see, this one, and this one. These are waxed up. That's waxed up. Could be somebody shoved a screwdriver through it, but this one's not waxed up. But the radio is tuning 14 and 14, and that last one is the local oscillator. There's nothing to adjust. They don't want to fool with the two that are waxed up. We're just going to leave them. So I think that's it for aligning that band. Wow, I got 3 more to do. That's pretty rough. Let's where are we for time here? 10:30. Yeah, I'd like to get through this. Okay, I'm going to stop for a bit, and we'll try one more band and see how that goes. From time to time, I find errors on the information that comes with these radios. Usually, it's not very consequential. With this one, I had to find on this diagram 2 adjustments. One was C49, and the other one is C60. So I'm looking for C60. I can't spot it anywhere in the list here. And then I think, well, I know where it is actually. I know. Here's C49 right here. I know it's right here. C60 has to be here. This one here. C60. Look what somebody did. C60. This reminds me of when I was working full-time and I was in a meeting, a small meeting, and we had a student in the meeting because we had students work in the summer in the company. And so he's just sitting in the meeting and we're talking away, and suddenly the boss says, "Hey student," he hands him a $10 bill and says, "Get me 6 coffees." And the student takes off. And so we got coffee coming. Wow, that's pretty good, coffee at a meeting. So we work along another few minutes, and then he returns and he hands back the $10 bill and 6 photocopies of the $10 bill. No, not 6 copies. Anyway, okay, funny story. There we go. So now the radio is tuned to 11.5 megahertz. The signal generator is set to 11.5 megahertz. I just want just below the number like that. Yeah. So there we are. And we don't have the speaker hooked up. Let's hook the speaker up. So I can hear the static, but I don't hear that. So I'm double checking now. 11.5. Sure. This is on the proper spot. Let's find out. Where's the radio really tuned here? Ooh. Is that feedback? Feedback through the signal generator? Wow. That's what it sounds like. That's hard to believe. The speaker's a long ways away. Can it possibly shake my signal generator enough to cause it to feedback? I doubt it. That's a weird thing. Okay, ignore the weird thing because there's already too many weird things going on. So if we have this at 11, what did I do? At 11, put it back to 11 where it should be. 11,500. This is still tuned to, yeah. So we'll look on the SDR now and we'll find out where is the local oscillator. It's supposed to be at 13,150. Let's take a look. So, oh, here it is already marked. It's 13,105. This should be 150. So we'll move the line to where it should be. That's where we got to get the local oscillator to. The oscillator adjustment is you know what? I got to check to be sure. Oh, here it is. Yeah, no, it's this one. It's definitely this one. I'm sure. Oh, sure enough, I'm going to move it. Okay, I said this one like you're looking in the camera, but you're not. So here we go. I'm making the adjustment. We're moving it. It's not moving. It's stuck. It moved. Now maybe it's looser. I'm not sure what the horn is. Let me turn it down. Well, that looks to be right on. Maybe just not quite. There we are. Okay, so now the radio should be tuning 11,500. That doesn't make sense, does it? 1350. Wait a minute. What am I doing here? Wait a minute. What's going on? I'm way off. I'm way off, but it all worked out. How's that happen? Now wait a minute. If it's not 1350. What did I do here? Let's try it again. Maybe it is 13,150. Yeah, I think it is. If I do it again, 11, because I'm just too stupid. 11,500 plus 1650. That didn't work. Let's try. Just bear with me here while I try to add some numbers up. 11,500 plus the 1650. Yeah, 13,150. That's exactly where we are. So this radio should be. Boy, you can just barely hear it there. Now, let me just move the signal generator. I'm gonna actually flip the camera here a little bit. Here. Okay. We're just right on the edge of this. Yeah. And no modulation. It's right on. Excellent. Stable and everything. So now we have a couple other adjustments to do. Let me just check myself here and take a look. Next adjustment is the C49 mixer trimmer. Okay. The C49 mixer trimmer. Let me take the speaker off. So the 49, that guy. And I'm trying to make this meter go as high as I can get it. Here we go. Okay. Are you going up? Going down. Going up. Going up. To there. That's the spot. Excellent. And now the last one to do is the antenna trimmer again. Why do they want you to do this even? Let's see what happens. It's pretty much at the top anyway. Like there isn't a trimmer, I don't think. So I don't know why they want you to do that, but you do it. Okay, hey, that's done. Hey. That's done at the high end. Now we got to do the low end. The low end is done at 5. So we'll tune down to 5. Okay, we're right on 5. Put the speaker back on. Now we'll tune the signal generator down to 5. Up to 5. Wow, it's just dead on. Look at that. You'd think I already aligned this thing. Wow, that's fantastic. Okay, taking off the speaker. see the meter over here. The next one is to do the mixer trimmer. Oh, these are slugs. Yeah, L7. Let's see what that looks like. There's another waxed up one. Just soon stay away from those if I can. Let's just see. Put the speaker back on. It's right on the money. It's right on. That's just fine. The other adjustments, I'm going to leave them. Yeah, I think I will. They're waxed up. I'm going to do this thing again. Okay, that's great. So on to the next band. Really, this is that turned out to be really well aligned. I guess one of the things you would expect in a high quality receiver is that it will hold its alignment for an extended period, like decades. And that seems to be the case here, or did somebody align this just before I got it? Who knows? No, I think this has been sitting idle for decades somewhere. That's what I think. Okay, so the next one we do at 4.6 and at 2. So 4.6. So we'll have to dial our way up there. 4.6. Okay, that's 4.6. Not so strong here. Okay, 4.6. How accurate is it? Oh, it's so close. I mean, really. I'll put this up and tune it in. And we'll see how far off it is. And it's nothing. I'm looking at the dial here on the radio. That's good. That's excellent. So local oscillator wise, fantastic. And the other ones are just an oscillator slug at the 2 megahertz setting. L10. Look for L10. L10 is waxed up. So we're going to leave it. Okay. But it didn't do anything to this band. Now we're going for the treble band. Yep, the treble band. So this one we do the high end at 1.4. So we'll find 1.4 is right here. Okay, tuning it without parallax. There we are, 1.4. This band has not worked well yet. So this is the one I think maybe we're going to get somewhere. So 1.4. Ooh, 1.4. Where are you? How can it be way up there? Wow, no wonder. Something's way out on this one. So I'm going to set this to where it should be, 1.4, and we're going to look for where the local oscillator is. So first of all, the local oscillator, you know what could have happened here? Somebody could have aligned it using 455 and not realizing the type of IF that are in this radio. So 1650 on top of that, surely I can do that in my head. 1650 be 30... 1400 plus 1650 equals 3050. So it should be at 3050. 3. That's what the radio tuned to 14. Did I do that right? Did I just do that right? I think I did. Do it again. 14 plus 1650. Didn't work. 14 plus 1650. Yeah, 3050. 3050. Let's go look at the SDR and see what we can see here. Okay, 1650. So we want to go down to the broadcast band here, or in the area. So we're already in the area of 6. So no, we're not. No, we're not. 1650. Maybe that's it there. So it's not very strong. I'm going to move the pickup coil. You can see all the weird stuff that's in there inside this radio. So it should be in the oscillator area. Wow, schmozzle. We're supposed to be at 3,000. It's not even on the screen, Jim. Come on. 3,000. Way up here. Way up in this area. There it is. That's supposed to be at 3050, not where it is. Okay, let me hang this somehow here. There we go. Just hanging the coil on the radio. So we're supposed to be at 3050, where the red line now is. Okay, let's move it up there. The oscillator for that is what? Uh-oh. Okay, I'm gonna have to take a look at the at this. We're starting with C62 oscillator trimmer, and then I see at the bottom C71 oscillator pattern. So trimmer C62. I'm looking at the diagram. Did they write C62? Oh, it's way up out of view there. Okay. Now we'll go back to the SDR. Okay, and I want to move this guy to where the red line is. How did that happen? That's where I wanted to move it to there. Okay, I'm going in at the and just putting in the alignment tool here. Okay, we're in. We're moving. Whoops, fell out. Not sure why it's so scratchy. Down on the volume there. Well, 1400 came in at 1400. Just as it should. So that worked just as it should. Now, why did it fade out just now? Because the control I just adjusted is relaxing. Okay, don't relax. Pick the right control. I almost moved the wrong one. Okay, we're in. Oh, I'm affecting it, am I? I gotta look at two things at once here. So this is me tapping the control, the trimmer with the screwdriver. Not doing anything. Okay. Trying to adjust it, this hair amount. There, that's it. That's it. Wow. That's it for that step. Now the next step. Next step is the mixer trimmer 47 and the antenna trimmer again. No, this time it's C2, C2, C2 every time. There's some reason I ask you to adjust the antenna trimmer. I don't know what the reason is for doing that. You think actually you'd want to do it maybe ahead of doing the mixer trimmer. I don't know. Okay, so C47 is next. C47, I'm looking at the diagram. There it is. There it is. Okay, let's go back. We want to look at the camera now. We want to look in the camera at the meter. Okay, and we're gonna take off the speaker so I can turn it up. Put the meter up on the dial. Now, peek that meter. Peek that meter. So you can kind of see what I'm going at here. Peeking the meter. Very close. Tiny improvement there. And then the last one, I will look on my own here. Oh, it's the antenna trimmer. Okay, antenna trimmer. Oh, it's still having quite an effect. Oh yeah, look at that. Okay, it'd be interesting to check this band once it's all done. Now we got to do at the low end nothing but an oscillator pattern. At the low end at 600. Okay, so we're down to 600. I think if this string thing was working better, you could spin this dial and get somewhere with it. So right on 600. Very good. 600. Let me put the speaker on. Where's the sound? She's silent. Okay, that's why we're doing this. So 600. Where is it? Where is it? What am I doing wrong here? The volume is full. You can't hear a thing. Let's look where the local oscillator is. Excuse me. So at 600, we should be at 1650 plus 600, 2250. $22.50. It's right here. Okay, so because once again I just had so much doubt about myself, I got the calculator out here, and we're at 600. We want the local oscillator to be 1650 above it. Calculator doesn't work well. It's all the fault of the calculator. Wait a minute, am I the calculator? 2250 is where we should find it. Right where I am here, 2250. That's an interesting question. Where is the local oscillator? Maybe that's it just to the left. So I'm going to tune the radio a little bit here. Tuning. I'll tune it with the band spread. Maybe that's not enough to see it. Okay, tune it further. Ah, that's the local oscillator. It's way off. So this is a case where looks like the radio is not tracking. Like there's a number of different things that have to track along as you tune, and with one of them out like this, it won't track with the others, and that's why you get a pretty quiet radio. Okay, so we want to move that, and we want to do it with what was it again? Don't try to remember. 71, C71. Okay, I'm going to see 71, C71. There it is, and there it is. Oh, it's tucked way behind there. 1, 2, 3. 1, 2, 3. Yeah. Okay. This also might require some back and forthing at both ends of the dial, because as I move this, the other end may move a little bit too. But this should kind of like stretch the local oscillator range to match the radio's tuning. Here we go. Wrong way, man. Okay, what that noise was, I don't know. Okay, so we've got this at this end. Actually, my signal generator's gone up. Let me turn it down. Okay. And the tuning, I'm just double checking to make sure it's right on the money. Everything is good. Okay, final adjustment here. You know, I'm doing all this, and there can be weaknesses in the radio I haven't detected yet. But that is kind of the idea. Get this alignment thing out of the way. So there's no question about the alignment while I then look for other deficiencies. Or maybe this is corrected now. So I've got a broadcast band that wouldn't really pick anything up. Down to the other end now. This is the other end, Jim. Back up to the top. You know what I just did? I just adjusted the wrong capacitor. I didn't adjust it much. Okay, back up to the top. We're going to the top. 14. Do I still get 14 at 14? It's so easy for me anyway, to make a mistake here. So 14, here we go. I'm doing the signal generator up to 14. Something funny about that. That's 1460. That's 14. There's nothing there, so I did something bad. So one of the easy mistakes is to turn the wrong adjustment, and that's what I did. So now I'm going to turn the right adjustment. How am I going to do that? I'm going to double check because my head is going crazy. So I'm up here at 1400, and I want to adjust the C62. I don't think I made a mistake. Anyway, C62. Let's adjust it. C62. Right. C62. We're at 1400, and I got to calculate this again. We're at 1400 at 1600. Wasn't that 3050? $3,050. That's where it should be. Do the right one now. Okay, now I'm just double checking everything here. 1400 on the signal generator, 1400 on the radio dial. Can't beat that. Back down to the other end now. Okay, so I'm at 600. Signal generator to 600. That's 575. Very important to get this to track right on this band in particular. Okay, signal generator at 600. Oscillator should be, I can't remember the number. 2250. That's the number. Should now be at 2250. So this is 2250. 2250. Move it up there. The proper one is C71. C71's the one in the corner. This is the one I think I did wrong, but I probably didn't do it wrong. But then, because I thought I did it wrong, I didn't did it wrong. Here we go. Okay, here we go. That looks good. That's 600 on the signal generator, 600 on the dial. Very good. I'll go back up to the other end now. Back up to 14. I think they don't like to do it right at the end of the capacitor's run, because funny things happen with the capacitor right at the end. So they have to, instead of doing it at 1600 or something, they're doing it at 1400. I think that's the idea there. 14. So that's 1412. Very close now. It's 14. I think I can just. It's supposed to be, was it 3050? Yes. 3050. Right there. Ooh, so close. Right there. So close. Doing the correct one now. The correct one is 62. 62. Wait a minute. No. Don't go by memory. Don't go by memory. 62 at the 14 end. 62, good. Okay, 62 is the right one. Looking on the chart. Okay. 62. This is 62. A little awkward here. There we go. Bring her in. Bring her in, buddy. Okay, that's good. We say we go to the other end again. Then we'll check in the middle. We'll see, because the middle may be out. We can get. I think that's the radio becoming more sensitive. That sound you're hearing? It's interference, not from the radio. It's from something, some upsetting thing here. Okay, so we're going to dial in 600 on the signal generator. We're just the tiniest bit low. Okay, adjusting this one. Just listening to it this time. Here we are. I think that's probably enough. It's probably enough. Very good. Wow, let's see what's happened. Let's just put this on the antenna now and see how it does at picking up ham radio. So come off the somebody goes down there. Put the antenna on the outdoor antenna. So this band was silent, pretty much silent, anytime I tried it. Let's see what happens now. First of all, even though it's interference, it's loud. Okay, so we're at 6. We should get a station at 590. Whoops, wrong dial. Beautiful.
There's never a good time for this, but it does seem like he was able to flip the page quickly, at least in talking to you, and this maybe won't be linear when he actually gets into it, but into trying to see the positives.
So selectivity is behaving normally now.
No, that he's going to have some ups and downs with that, and that he's just going to try to do his best for...
The signal strength appears higher on the 2.5.
he's going to have to fight through some of that negativity. But
Tuning.
he's had to do a lot of growing up in a lot of ways over the last year and a half, right? He's faced baseball challenges that he'd never before experienced. He's had some periods.
Okay, let's see about sensitivity. We'll pick up some other stations. This is the strongest station out here.
Obviously different.
That's impressive. This is Buffalo. This is WGR Buffalo. 610 St. Catharines. How about the automatic noise limiter? Oh, wow. That,
Now advisors in Ottawa suggesting that this is the way to go. I would suggest to you that the results from the Kathleen Wynne election speak for themselves. Hiding.
640.
By diversion.
680.
Place for about an hour yet.
710. No, 710's a tough one. 740.
Travel insurance. You book your trip. So when you are going to book travel,
It's a great station, 740. Plays old-time music, just like when I was a kid.
where you're going.
Not right now, though. Radio's working good. Let's go way up here. Oh, yeah. 1430. Community radio from Toronto. She's good. Wow. Okay. Isn't that something, eh? I could have chosen a different approach here, and I could have said, well, probably the alignment is not the issue, and there's some defective part. I've got to find it, and I could have spent a lot of time looking for it. Turns out the alignment was off enough to pretty much quiet this radio on its broadcast band. Really make it sound dead. So that's wonderful. Let's check the calibration device here. It's supposed to be every 100 kilohertz. So there it is there. Yeah. Excellent. It's all excellent. Now there's more to do. There's more adjusting and stuff to do with this radio, but the bulk of it is done. Fantastic. I'm really happy. This is a really nice radio. I like it. Thanks a lot for watching a long video, but I got through what I wanted to get through. Tomorrow we'll try to do the rest of the adjustments, like the BFO and a few other things that need to be adjusted. Then assess the radio, and that's probably it. It's probably done. Fantastic. Well, thanks so much for watching today, and thank you very much for clicking the like button. And the like and the like percentage are what I pay attention to. I don't pay attention to too much else, and so that tells me if I'm doing okay or not at these videos. And thank you very much for the super thanks. I really appreciate that too. See you tomorrow. Bye.